Hello everyone, today we're going to be doing an overview of graphing and for college prep math. These notes directly correlate with College Bridge Unit 8 over graphing, so you are more than welcome to use these notes to help you on that unit. Let's jump in. So the first thing that we are going to be looking at is the attributes of a coordinate plane. A coordinate plane is something we have seen before. It's just a blank graph with x and y and all of the things. So we're going to break it down a little bit. So as we have talked about a little bit before, this vertical line here is our y-axis. And a y-axis runs up and down because our y values run up and down. One unique feature of our y-axis is that it also splits our x values in half, because since y runs up and down, x runs left and right. So that means we can also call this y-axis x equals 0. And on the other side of the coin, this horizontal line is our x-axis. And since x runs left and right, it actually splits our y values that run up and down in half. And so we can also call this line y equals 0. And so this right here, y equals 0, x equals 0, that is a unique feature you need to keep in mind as you are plotting points. And then because of these two axes, our graph is split up into 4 quadrants. And so they are ordered in a counterclockwise fashion. So this is 1, this is 2, this is 3, and this is 4. Notice I use Roman numerals for these. We always use Roman numerals to identify these quadrants. Quadrant 1, its characteristics is that x is positive and y is positive. So this is my positive quadrant. Everything is always positive. On the flip side, quadrant 3, everything is always negative. X is negative and y is negative. That is because it is on the opposite side of both my y and my x-axis. So these two are directly opposite of each other. Now 2 and 4 are a little different. So going from 1 to 2, we cross over the y-axis, and notice x is 0 at the y-axis. So that means when we go to quadrant 2, x is now negative. But we stay above the x-axis, so y stays positive. So here we have it mixed. X is negative and y is positive. Now, similar to 1 and 3, 2 and 4 are opposite of each other, because you notice that they are on the opposite side of both x and y. So that means on this side, x is positive, because again, we're to the right of x equals 0, y-axis. And y is negative because we are below that x-axis. So 1 and 3 are opposite, 2 and 4 are opposite. Now, whenever we're trying to identify points on a coordinate plane, we always write them as x, comma, y. So you always write the x value first, y value second. If you ever have trouble remembering that, just think it's always in alphabetical order because x comes before y in the alphabet. Now, moving down, a linear equation is something that we can plot on a coordinate plane. Linear equation, as it might imply, is a line. It is a straight line. It can either be positive, negative, flat. It can look a bunch of different ways. And so this equation right here, y equals mx plus b, is what we call slope-intercept form. And slope-intercept form is the way that is the form of a linear equation that we can plot on a graph. Because we always plot equations when they are in terms of y equals. That is the only way we can graph an equation. And so to break this down a little bit, x and y are simply x and y. All right, they have no special meaning. If you plugged in an x value with everything else, you would get the corresponding y value that is on your graph. M and b, however, have actual numbers. M is what we call our slope. The slope is how quickly your graph is increasing or decreasing as you move from left to right. We always read graphs from left to right because that is the same way we read our words, sentences, and all things in English. Our slope is broken down into rise over run. So, just an example, if I were to have a slope of 2. So 2 is not a fraction, but it is an implied 1. We talked about that in our fractions unit. So since 2 is positive and y is positive as it goes up, that means going from one point to the next with this slope, we would go up 2 units. And then again, we always read graphs from left to right, so that means we would go to the right 1 unit. And it would be the same, it would be a similar idea if 2 was negative. Since negative is where y is going down, we would go down 2 over 1 if 2 were to be negative. B is what we call our y-intercept. And so our y-intercept is a point that is on the y-axis. And if you recall, at the y-axis, x is 0, so the coordinate point for B would be 0, comma, B. And B will be some number in an actual equation. So if I were to give you this example, like what is the equation of a line that has a slope of -2 and passes through the point 0, 4? We know slope is m, so this would be y equals -2x. And then we know that the point 0, 4, we know that directly correlates with our y-intercept. So we know that b in this case is going to be 4, so I'm just going to say plus 4. So that is your linear equation broken down. Now I'm not always going to say, hey, the slope is -2. So you need to also be able to calculate the slope of a line using the slope formula right here. This is y2 minus y1 over x2 minus x1. Your y values are on top because, again, that's related to rise. That's related to either going up or down. And then x2 over x1, that is related to moving left and right. And we always move to the right in relation to the denominator of our slope. So let's try 2 points here. Let's try 3, 4, and 6, 8. Okay, moving left to right, 3, 4 comes first, so this will be point 1, and this will be point 2, because, again, coming left to right, you see this one first, and then this one second. So plugging it in, y2 would be 8, minus y1 would be 4, over 2, in this case, would be 6, so 6 minus, and then 3 would be x1, so minus 3. And so to simplify this, 8 minus 4 is 4, 6 minus 3 is 3. So my slope would be 4 over 3 in this case. So remember this slope formula, that will be super helpful later on. Now, we don't always just, plot regular, linear equations by themselves, just one line. We also have pairs of lines, and these two right here are unique pairs. Starting with parallel lines. Parallel lines are two lines that never touch. And they never touch because they have the same slope, but different b values. And it's a different b value because they're not the same line. They're just two lines that share the same slope. They don't share every characteristic. So to give you an example, that would be y equals 2x plus 4 and y equals 2x plus 1. So if I were to graph both these, starting with this top one, plus 4, remember that is my y-intercept, so that means it would be 0 along this line, and then 1, 2, 3, 4 for my y value. And then I have a slope of 2, so if you recall, that would be a rise of 2, and then that implied 1 on our denominator. So up 1, 2 over 1, and then we would connect the dots. My second line, just to see that they are parallel, I have an intercept of 1, that plus 1, and then it's the same slope. So up 1, 2 over 1, up 1, 2 over 1. So if I were to draw this line, you notice those two lines are never going to touch. They are parallel. They run side by side, and they're straight lines, so they are never going to touch each other. Now, perpendicular lines. They are the complete opposite. They do intersect, and their intersection creates 90-degree angles. All right, if you remember from geometry, a 90-degree angle, all right, that is perfectly square. And that is because their slopes are negative reciprocals. And what a negative reciprocal means, if you were to take a slope of, let's just say, a slope of 3. So negative means it now becomes negative 3. And then reciprocal means you flip the fraction. So this is an implied 1, as we've talked about before. So that means the perpendicular slope would be negative 1 over 3. So let's just try an equation with 3 and its reciprocal. So let's try y equals 3x minus 2. And let's try y equals negative 1/3 x. I don't know, negative 1/3 x plus 6. So minus 2, that would be down 2. And then slope 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 2, 3. So this would be my first line, connect the dots. My second line, plus 6, so that would be up 1, 2, 3, 4, 5, 6. And then this is negative 1, so we go down 1, and then 3 is how many we move to the right. So 1, 2, 3, down 1 over 1, 2, 3, and I connect those dots. And again, you notice you create that 90-degree angle. So keep in mind of those two special types of lines. Lastly, we're going to jump into linear inequalities. So instead of an equal sign, all right, because remember, equal sign means equal to, or its opposite, not equal to. These guys have a different meaning. So these two right here have that extra line. These have two options. So this one facing to the left is going to be greater than or equal to. This one facing the opposite direction is less than or equal to. Its counterparts that don't have the lines, this is just greater than, and the guy without that line underneath is just less than. So if you see that extra line underneath, know that those have two options. They are greater than or equal to, and I can't spell or apparently. That's or equal to. So let's try out a line. So if we do y is greater than or equal to 3x plus 2. Let's plot some points. So we know at this point that's an intercept of 2, and then we go up 1, 2, 3 over 1, up 1, 2, 3 over 1. Now these lines, when it comes to the line and all sorts of things, are different. So if you see equal to, so if you were to see greater than or equal to, less than or equal to, or equal to, you are going to draw a solid line because that means your solutions are included on the line. It's not just everything around it. The line itself is part of your answer. Versus if you have greater than, less than, or not equal to, you're actually going to draw a dashed line because that means not included. So this example I gave does have the equal to, so that means I would shade on the line. Now since this says greater than, that means y is going to be bigger. So we know y is bigger as it moves up, so you notice my y-axis, that arrow pointing towards forever big, is on this side, this kind of left side of my equation. So I'm actually going to shade everything because everything on this side is going to be bigger than my line. So my solution is everything to the left of this, all right? So now that is actually going to wrap up our notes. If you want more practice, again, please go look at College Bridge. Otherwise, have a great day.